Hi guys, today we're going to be studying Surds and I'm going to be your teacher, I guess. Help you go through it, and my name is Philip Taramwa. So for most of the topics we're going to be studying, we're going to use this book called Mathematics 1 written by J.K. Backhouse and S.P.D. Foldsworth as a reference book. Some of the exercises will come from there. So that's a book we will use mostly. So on to surds. What is a surd? So a surd is an irrational number, i.e. a number that cannot be expressed as a fraction of two integers. So a fraction is pretty much something out of something like 2 out of 3, 3 out of 5, as you can see there. So that would be a fraction, and then we have a surd as root 2, and root 2 cannot be expressed as a fraction of two integers, and that makes it a surd. So yeah, that's what we define as a surd. I'm going to do, first of all, simplification of surds, one of the easy parts of the topic. The first rule, and the rule we use mostly, is the fact that root of a times root of b is equivalent to root of a times b. And we're going to use it very much in the simplification. So we have root of 2 times root of 3 would be root of 2 times 3, which is root of 6. So I'm going to use a dot to represent the multiplication. We'll do it a lot. It's going to be used interchangeably with a multiplication sign, which looks a lot like an X. So yeah, in this case it means multiplication. So root, in the same case you could go backwards. So root of 8 would be root of 4 times root of 2, which would be root of 4 is equivalent to 2, so you would have 2 times root of 2, which is the same as 2 root 2. So in the same way we could take it the other way around. Again, 3 root 2 could be root of 9 times root of 2, which is root of 9 times 2, which is root 18. Let's have an example of simplification. I have root 50 plus root 2 minus 2 root 18 plus root 8. So root 50 is the same as root of 25 times 2 plus root of 2 minus 2 root of 9 times 2, 18 being equal to 9 times 2, and 8 is equal to 4 times 2. So we could split it again. So because root of 25 times 2 is the same as root of 25 times root of 2, we'll have 5 root of 2 plus root of 2 minus, so we'll have 2 times root of 3 times root of 2. So I mean 2 times root of 9 times root of 2, and root of 9 is 3. So 2 times 3 is 6, so we'll have 6 root 2. I'm referring to the simplification of this being equal to this. So yeah, plus 4 root 4 times 2, which is the same as root 4 times root 2, which is 2 root 2. So you see you have all root 2's, root 2, root 2. So it's the same as having 5x plus x minus 6x plus 2x. So we'll, do board mass. We'll add first, and we will get 8 root 2 minus 6 root 2. So I'm treating the root 2 as an unknown, but it could be there are 8 root 2's minus 6 root 2's. So 2 root 2 I think would be the answer. Yeah. Now on to rationalization of the surds. Rationalization is pretty much removing a surd from the denominator. So if we had, like here, we had 1 out of root 2. 1 out of root 2 would be equivalent to 1 out of root 2 times root 2 out of root 2. So effectively, if you see here, this is equivalent to multiplying it by 1, because you have root 2 out of root 2, which is equal to 1. But because this is root 2, it will cancel out in the denominator because root 2 squared would give you 2. So 1 times root 2 out of 2. So yeah, that's what we'll get. So we'll get root 2 out of 2. So to rationalize is to remove the surd from the denominator. So now it's a bit different for when we have a denominator with two different, okay, like here we had only root 2, here we have 3 minus root 2. So when we have 3 minus root 2, what we do is we change the sign here and multiply it up and down. So we have 3 minus root 2, so we're going to have a 3 plus root 2, a 3 plus root 2, multiply it up and down. So the idea here is something called like the difference of two squares, whereby if I multiply this times this, it will give me this squared minus this squared. So we'll get 9 minus 2. You can try it out, take it slowly, step by step, because the numerator is obvious, and then here you do it slowly, step by step, and you will find that you will end up with a 9 minus root 2. So you will have a 3 plus root 2 out of 7. We shall expound more on that in some examples that we're going to do later on. Yeah, so that's the idea of rationalization, where we had surds in the denominator at first, but in the final answer we don't have any surds in the denominator. So now on to some examples. Given root 3 is equal to 1.732, simplify root 0.0675. So we have root 0.0675 will be equal to root 675 out of 10,000. So we split it. Find factors of 675. So ideally you should find how should I say, squares, perfect squares that are factors of 675. So here I have split it to 25 times 27 out of 10,000. Now 10,000 could easily be is a perfect square, so it gives you 100. So you have 5, because this is root of 5, root of 25 times root of 27. So we'll have 5 root of 9 times 3, which is again 9 is also a perfect square, so we could bring it out as well, because we would have root of 9 times root of 3, which is 3. So we would have 5 times 3 times root of 3, which would give us 15 root 3 out of 100, and 15 times 1.732 out of 100, because we are now bringing in the root 3, which would give us this answer that we have here. Yeah, hopefully you get that. Yeah, on to the second example. In most cases, they ask express in the form a plus b root c. It's a not simple, but it's a way of asking you to rationalize, i.e. remove surds from the denominator such that you can write it in terms of a plus b out of root c. So first of all, as I said earlier, for this case we first simplify, because root of 18 can be simplified, because this is root of 4 times 2, root of 9 times 2. 4 is a perfect square, 9 is a perfect square. End up with 2 root 2 plus 3 out of 3 root 2 plus 2. I wouldn't say that if you don't choose to simplify, it's wrong, because you could simplify at the end, but I chose to simplify at the beginning. So now again we change the sign. So what happened here is that I changed this sign from a plus to a minus. Well, you could change either the sign of the surd or the sign of this integer. You choose what you want to change, because either way the change of sign would give you perfect squares, and okay, no, it's not perfect squares, but no matter which sign you change, you would end up with the same answer. So you can try it out in your free time, where you would change this to, instead of being 3 3 root 2 minus 2, you can have 2 minus 3 root 2, and you'll end up pretty much getting the same answer. So no matter which sign of you change, as long as you change only one of the signs, you will end up with the right answer. And be careful, because you may end up with a negative, and the negative would have to obviously affect whatever is inside. So multiply by 3 root 2 out of negative 2. Again, we do it slowly. 3 root 2 times 2, so 2 root 2. So that 3 root 2 times 2 root 2. So that 3 root 3 times 2, then times root 2 squared. I don't know if, yeah, 3 times 2 times root 2 squared. So we'd have 6 times 2, because root 2 squared is 2. Then we have 3 root 2 times 3, which is 9 root 2. Then we have negative 2 times 2 root 2, negative 4 root 2, negative 2 times 3, negative 6. Then 3 root 2 times 3 root 2, which is 3 times 3. 3 times 3 times root 2 times root 2, which is 9 times 2, because root 2 squared is 2. Then 3 root 2 times 2, which is 6 root 2. Then negative 2 times 3 root 2, which is 6 root 2. Then negative 2 times 2, which is negative 4. So now on to the simplification. I hope you see that here, I was saying, I hope you see that here, here we have 6 root 2 minus 6 root 2, so we'll have the 6 root 2 cancelling, and then we'll have minus 4, so 9 times 2, which is 18, minus 4, 14. Then here we have 12 minus 6, like terms, so 12 minus 6, then 9 root 2 minus 4 root 2, so 6 plus 5 root 2. Then we simplify it to get 3 out of 7 plus 5 out of 14 root 2. Yeah. I would encourage you to go and do the exercise 9b in the book I earlier said. Do as many numbers as you can, because as you know, in math, practice makes perfect. Oh no, yeah, okay, the more you practice, the better you get, so practice makes better. So yeah, so I'd advise that you go and do as many numbers in that exercise as you can. The answers are there at the back. Yeah, and hopefully I will be able to link it to a PDF download in this video, hopefully. Yeah, thank you very much.